Welcome to the example for hypothesis testing of proportions about jobs. A researcher claims that more than 29% of U.S. employees have changed jobs in the past 3 years. In a random sample of 180 U.S. employees, 63 have changed jobs in the past 3 years. At a 0.10 significance level, is there enough evidence to support the center's claim? So again, I'm going to highlight the claim. It claims more than 29% of U.S. employees have changed jobs in the past 3 years. Since this is a proportion or percentage, we're going to use P for H sub 0 and H sub A. Our claim says more than, so since that does not contain equality, our claim is going to go with the alternative H sub A. P is greater than our percentage 0.29. So H sub A is P is greater than 0.29. That means H sub 0 should be P is less than or equal to 0.29. And I'm going to indicate that the claim is with H sub A here. I'm also going to assume from H sub 0, assumed the claim proportion is going to be 0.29, and we're going to use that for our calculations. And H sub A, since it's greater than, is going to be a right-tailed test. Our significance level, alpha, equals, and in our sentence it says it's 0.10. Our rejection criteria. We're going to reject the null hypothesis H sub 0 if our p-value is less than or equal to our significance level. In this case, it's 0.10. That leaves our test statistic and our p-value. Our test statistic is our z-test statistic. Remember, it's going to be p hat minus p, which is our claim proportion, divided by p, q over n. Let's look and find those values. For our p hat, we're going to have to use our sample and our sample size and our x value. So n, it says in a random sample of 100 U.S. employees, so n is 100. X is going to be 63 people have changed jobs in the past 3 years. That means it's going to be p hat is going to be 63 over 180. Let me pull that down for you. Let's see if that works out to be a decent decimal here. 63 divided by 180, and that is 0.35. If it doesn't work out to be a nice decimal, we'd have to just leave the fraction as it is. Also, we're going to need what Q is. Remember, Q is going to be 1 minus 0.29, which is our p-value. And so that's going to be 0.71. And we already have what n is. So let's substitute all those values in. P hat is 0.35 minus p, which is our claimed proportion. So we take the difference in those, and we divide it by the square root of 0.29 times 0.71 divided by, and again, 200, or I'm sorry, not 250, 180 is our sample size here. So we can use our calculator or other technology. I'm going to just go ahead and choose to use StatCrunch right away with this one, since we've practiced with the calculator a couple times. On StatCrunch, we're going to go Stat, Proportion Stats, one sample, and then with summary. Our number of successes in this case is 63, divided by the number of observations, or sample size, is 180. We perform the hypothesis test for P. H sub 0, P equals, and we're going to change that underlying assumption to 0.29. And our H sub A, we're going to do P, and we're going to change the inequality to a greater than symbol. I'm going to go down on my screen and make sure I hit the p-value plot and hit compute. So moving our screen here, you can see that our sample proportion, our standard error, our z-stat p-value, but I'm going to go ahead and click the bottom right arrow and see that our z-test statistic is 1.774 here, 1.774, and our p-value is 0.038. So I copied that down onto my paper. I can see the graph. I'm going to also copy that onto my paper. Okay, so on the graph, remember my horizontal scale is -2, -1, 0 being the mean, 1 and 2. Our test statistic we said was 1.774, so I mark that cutoff value, 1.77. Z equals 1.77. We said it was a right tail, so we're going to shade to the right, and the p-value is the area in that region, which is our probability. So our p-value in this case is 0.038. Now our decision. Remember, our decision comes from our rejection criteria. And we have to test our p-value to see if it's less than or equal to 0.10. So my p-value is 0.038, and I have to see if it's less than or equal to 0.10. I'm going to add another 0 there, and I can clearly tell that is definitely less than. So my decision then is I'm going to reject the null hypothesis. Now our concluding statement. Our concluding statement, I'm going to look at the chart. Remember, our claim was HA, it did not contain equality, and we rejected. On our chart, does the claim contain the condition of equality? The answer is no, because HA is just greater than. So we go down, and then we answer the question, do we reject the null hypothesis? And it says yes. So it should say the sample data does provide sufficient evidence to support the claim. So it does support the claim. Let's write that on our paper. We're going to say there is sufficient evidence to support, I'm going to capitalize that, is sufficient evidence to support the claim. And after we've done all this work, it kind of, forget what the scenario is all about, but I did highlight it. So it says there is sufficient evidence to support the claim that more than 29% of U.S. employees have changed jobs in the past 3 years. And we can say at alpha equals 0.10. And there we go.